What's poppin', dogs? Mr. Allen here solving some exponential equations in this video that require the use of a calculator. So bust that bad boy out and let's get things started here. We got 2 times 3 to the x equals 10. How do I start this? Well, our goal is to get to x, right? So we have to algebraically, legally get there. The first thing I'm going to do is divide by 2 on both sides. So now I have 3 to the x equals 5, right? 10 divided by 2 is 5 last time I checked. But now what do I do? Because without a calculator, we often look for like the same base, use the one-to-one property, but I have 3 to the x equals 5. Well, it's between 1 and 2 because 3 to the first is 3 and 3 squared is 9, but I don't know what it is. So let's do this. Let's loop it. Let's swoop it. Let's rewrite it in log form. And I'm going to have log base 3 of 5 equals x. And if I can just type that into my calculator, we've got our answer. So here's how you do it. My favorite shortcut. Math, alpha, math. So it's the math, the button right above it that says alpha, and then math that chooses choice A and allows you to type in any log base you want. So I got 3, I got 5, hit enter. Boom. We have 1.4649. So let's say 1.465. So x equals 1.465. Boom. Awesome. 3 decimal places. That seems appropriate for this. And you know what? We can actually test it. Check this out. 2 times 3 raised to the 1.465. That should be really close to 10, right? That's really close to 10. If I would have done 2 times 3 raised, and then I went up and I actually grabbed my answer from before, then I would get 10, right? Because, you know, yo-ro. You only round once. But when we round it here, then it gets slightly up. See, the rounding, you get less and less accurate. That's why we only round once throughout the problem so we get the most accurate we possibly can at the end of the problem. All right, next one over here. I have 5 raised to the x minus 4 plus 6 equals 20. So how do we start that one? Well, how about I subtract 6 on both sides first? Again, normal algebra is going to apply here. It's just how we get to the exponent is a little bit different now that we know logs, right? So we have 5 to the x minus 4 equals 14. All right, so now I got to rewrite it in log form so that I can solve for the exponent. That's the purpose of logs, right? Before I couldn't get to my exponent. Like there wasn't a way to do that. So if there's not a way to do that, you got to learn new math. That new math is logarithms. So now I have log base 5. That's the first thing. That's what I start with. The base is always the base equals 14. So now we have log base 5. I always start with that base, right? The 5 is the base here. The 5 is the base in my logarithm of 14 equals the exponent, which is x minus 4. Now, I'm going to plug this into my calculator, but there's one more step that needs to be done to solve for x. What is that? Well, I got to add 4 to both sides, and I love doing this all in my calculator. It makes my life a little bit easier. So here's what we're going to do. Math, alpha, math, voice crack. I got a base 5 of 14, hit enter, there's my decimal, and I can just add 4 to that, and my final is 5.6397. So a lot of times I think your teacher's probably going to want to see like, oh, you got 1.6397,639, and I put like a ... to show that I'm still mathing, right? And then I add 4 to both sides, and we're going to get x equals, so we'll put x equals here. I don't want it to get in the way of the calculator. X equals, let's see here, 5.6397. This one always freaked me out in high school. I was like, wait, 3 decimal places, but what happens with the 9? It's going to be just 5.64. Sorry, yeah, 64. All right, that 9 gets rounded up by that 7. You can even put 640. Either way is cool. Actually, on like math team, they require 3 decimal places, and they'd be like, make sure you put the 0 there. You don't have to have the 0 there. You can. Whatever. There we go, guys. First two done, next two. And these are all different scenarios here, right? Of like the algebra that's happened. Like this one here, I can just start right away by rewriting it in exponential form. So I'm going to do that, loop and swoop. And I'm going to have log, this is interesting, base of 1/2 of 24 equals 6x. So once again, plug this in. And by the way, if you're like, oh man, I don't have the math alpha math, you can do change of base, and some of this is a test question. Check this out. I'm going to do math alpha math to start, okay? We got the 1/2 or 0.5, and then I have 24. But you could also have typed this in as just a regular log of 24 divided by a regular log of 0.5, and you'll get the same exact answer. That's called change of base, and I've seen that on the ACT and SAT. They say which of the following is equivalent, and they make you choose the fraction, okay? Either way, you'll get the right answer. I like the math alpha math. They got them on the newer calculators, right? And then what am I going to do with that? So let's write that down. I've got negative 4.584 and change, 584 dot 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 equals 6x. How do I finish solving here? Well, I'll divide by 6 on both sides, and I get x equals, divide by 6, boom, we get negative 0.764. 764. Final answer. And notice, guys, I did not retype my answer. I just hit division, and it has A and S there. That brings the previous number down. Had I rounded that previous one, negative 4.585, it may have made a minor difference, but probably not much here. I got the same answer. It's slightly different, as you see, right, in like the fourth decimal place. But again, pending the situation, the rounding throughout the problem really makes a difference. Sometimes it doesn't make a whole lot of difference. Like this one didn't. Other ones, it makes a huge difference. So just to be careful, wait till the end of round. You only round once. Yo-ro. Okay. Enough with the yo-ro pitch. But you should definitely live by the law of yo-ro. Okay. It's in your best interest in the mathematics, guys. Last one here. Let's subtract 1 first. I get 4 to the x over 2 equals 6. Now, we got to loop and swoop this bad boy. Throw it into logarithmic form. Log base 4 of 6 equals x over 2. So let's math alpha math this thing. Plug into our calculator. Math alpha math. I've got 4, 6, enter, 1.292 and change. So 1.292 dot 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 equals x over 2. How do I solve for x here? If I'm dividing by 2, multiply, oops, not by x, multiply by 2. That is the world's ugliest 2 right there. Oh, that is awful. I'm so sorry. But anyways, that cancels the 2's, and I'm left with, let's see here, times 2 in my calc. I've got x equals 2.5849, so 585. Nice. All right, there we go, guys. 4 rather different scenarios, all kind of the same type of problem, right? We're solving for x, which is in our exponent, but the start of them was all a little bit different, right? And the end of them was a little bit different. So this one didn't require any steps thereafter, but the rest of these did. So depends on the situation. These were all really like 2-ish step type of algebra besides the moving into log form. They can get a little bit crazier than that. I'm going to make another video where they get a little bit crazier than that. So if you're like, bro, I saw some that were crazier than that, I need a video on something that's crazier than that, I got you, okay? I'm going to make another video. It's going to be published after this one at some point, so be on the lookout for that, but I promise you I have another one that is coming that'll be more crazy than this one. Thank you guys for watching. If you have any questions or requests for other videos, pop them in the comments. Otherwise, have a dope day.